In this lesson, we are going to be discussing 2 additional ways to solve systems of equations. If you remember, in the previous video lesson, you learned how to solve a system of equations by graphing the 2 equations and finding their point or points of intersection. The 2 methods for today are algebraic methods, meaning we're not going to graph them. We're going to use arithmetic and use our properties of equality to find the solutions. So no graphing necessary, but lots of algebra. The 2 methods we're going to discuss are substitution and elimination. We'll spend the first part of the lesson illustrating how to solve with substitution, and then the second part with elimination. Once you know all 3 methods, graphing, substitution, and elimination, then you have this toolkit that will let you solve any system, because different systems may have different advantages or different solution methods which will work better for other systems. Okay, so I'm going to give you the steps for substitution. Take a minute, I want you to jot them down. The steps are good to have handy. Now let me tell you, when you first read these steps, don't be surprised if you look at them and think, I have no idea what those mean. I'll illustrate how to solve using the steps, but I just want to go ahead and get the steps kind of out there so that you're familiar with steps 1 through 4. First step is solve for one variable in at least one equation. And again, this is if necessary. Substitute the resulting expression into the other equation. Notice how we're using the word substitute. That's why we appropriately call it substitution. Then you're going to solve that equation to get the value of the first variable. Substitute the result into the other, and then write the answer in an ordered pair. Again, if you read these 4 steps and you think, okay, Mrs. Evans, I have no idea what any of that means, that's perfectly normal. Let's illustrate these steps with an actual problem. Okay, here's the system. Y equals 2x and y equals x plus 5. So look at step 1. Solve for one variable in at least one equation. When I look at these 2 equations, I see that the first equation is solved for y, and I see that the second equation is also solved for y. But since we already have one equation solved for one variable, then we're great. Okay, step 2. Substitute the resulting expression into the other equation. So what I'm going to do is I'm going to take 2x and I'm going to substitute it in for y into the other equation. So that would be 2x equals x plus 5. I replaced the y with the 2x. So when you have 2x equals x plus 5, it's now an equation with one variable and we can solve it. So I'm going to start by subtracting x from both sides. 2x minus x is x, and so I get that the value for x is 5. Alright, so that was actually step 3. Step 4, substitute that value into one of the original equations and solve. So if I have y equals 2x, and I now know that x is 5, I'm going to substitute in 5 for x, and then 2 times 5 is 10, so that'll give me my y value. And then the last step, write your answer as an ordered pair. So if x is 5, y is 10, I'm going to write the answer as the ordered pair, 5, 10. And this is the answer I would want you to give me. Alright, now let's check it. See if I can squeeze some room in here. Does 10 equal 2 times 5? And does 10 equal 5 plus 5? I put the x and y values into both equations. Okay, so in this one, 10 equals 2 times 5. Yep, 2 times 5 is 10, so it works. Does 10 equal 5 plus 5? Well, 5 plus 5 is 10, and it works. This is our solution. All right, let's try it again. Step 1. Solve for one variable and at least one equation if necessary. Okay, so when I look here, I see that my second equation already is solved for y. And that's great. I don't have to do anything for step 1. What I'm going to do is I'm going to substitute in this expression into the other equation. So that would be 2x plus, and then instead of writing y, I'm going to write x minus 4. I like using the different colors. 2x plus x minus 4 equals 5. So I substituted in x minus 4 in for y on the other equation. Okay, 2x plus x is 3x. Then we have minus 4 equals 5. We'll add 4 to both sides. So 3x equals 9. Divide both sides by 3, and x is 3. So that was our step 3. We're now going to substitute 3 into either the first equation or the second equation. I'm going to choose to put it into the second equation. I'm going to say that y equals 3 minus 4. Therefore, y is negative 1. So my solution would be the ordered pair 3, negative 1. And then let's check it. Does 2 times 3 plus negative 1 equal 5? And does negative 1 equal 3 minus 4? Okay, on the first equation, 2 times 3 is 6. 6 plus negative 1 is 5, so yes, it works. 3 minus 4 is in fact negative 1, so it works. We know we're moving in the right direction. Okay, see if you can work this one on your own maybe. Press pause, and then when you're ready to check your work, press play. All right, if I follow this with the steps, step number 1, solve for one variable and at least one equation. Okay, this is a case where it's necessary. Neither of these equations are solved for one variable. A good trick to this is when you solve for a variable, maybe pick a variable whose coefficient is 1. Like this x could work, this x could work, this x could work. You probably want to stay away from the 4y because that would involve dividing by 4, and that might also involve some fractions, which, none of us like working with fractions that much. So choose one of these variables, anything that has a coefficient of 1. I'm going to choose, how about solving for this x? How do I solve x plus 4y equals 6 for x? Well, that means I'm going to subtract 4y from both sides, and that would mean that x equals 6 minus 4y. I'm now going to take this and substitute it into the other equation. Be careful not to substitute it back into the original equation, because then everything's going to cancel itself out and you're going to get a false no solution. Make sure you're putting it into the other equation. Other equation. Okay, so what that means is I'm going to have 6 minus 4y plus y equals 3. Collect like terms, so negative 4y plus 4y is negative 3y. Then I'm going to subtract 6 from both sides. So negative 3y equals negative 3. Divide both sides by negative 3. and y would be positive 1. Okay, now we're going to substitute that back into one of the original equations. So how about I do a little dividing line here. How about I do x plus 1 equals 3. If I subtract 1 from both sides, that would mean that x is 2, and my ordered pair solution let me pause it for a second. Okay, sorry about that. Let's try resuming to where we were. I lost all of my inkings, but if I work this quickly again, I solved this equation, and I made it x equals 6 minus 4y, which I then substituted into the other equation, 6 minus 4y plus y equals 3, which became 6 minus 3y equals 3. And negative 3y was negative 3, therefore y was positive 1. So if I substitute positive 1, that would be x plus 1 equals 3. Therefore, my x value is 2. So the ordered pair solution is 2, 1. And if I check that, 2 plus, I'm up here at the top, 2 plus 4 times 1 is 6, and 2 plus 1 is 3, so I know it works. All right, let's try one more. Step 1. Solve for one variable in at least one equation if necessary. Okay, so when I look at these, I only see one variable that would be pretty simple to solve for, so it's this x. So I'm going to make this x equals 11 plus 4y. And then I'm going to substitute this into the x on the other equation, and it'll look like this. 4y minus 5 times 11 plus 4y equals 9. Notice when you distribute, you have to distribute that negative 5 along with it. So it would be 4y minus 55 minus 20y equals 9. Okay, so collect like terms. That would be negative 16y minus 55 equals 9. So we're going to add 55 to both sides, which would make negative 16y equal positive 64. Divide both sides by negative 16, and you should get that y is negative 4. So that was step 3. Step 4, substitute negative 4 into either of the other two equations. I'll draw a little line here. So how about I put in y on the second equation? That would be x minus 4 times negative 4 equals 11. So x plus 16 equals 11. Subtract 16, therefore x is negative 5. And my ordered pair would be negative 5, negative 4. Let's move on to the second method. The second method is called elimination. Again, I'm going to give you all of the steps. Jot them down. They might be a little wordy, but they're good to know before we go into the solution process. So step one, write the system so that like terms are aligned. And we want them aligned vertically. Then modify one or both of the equations so that one set of variables are opposites. You'll see what that means in a second. Combine the equations to eliminate a variable. This is why we call it elimination. And solve for the other remaining variable. Then substitute that value into one of the original equations and solve for the other variable. And then write your answer as an ordered pair and then check your answer. Okay, again, that's really wordy. I get it. Let's try it out. Step one, write the system so that like terms are aligned. Okay, this is already done for us. Do you notice how the x's and the y's line up vertically, and then these constant values line up vertically? This is what you want to get. Putting the equations into standard or general form is a really good tip for this type of method, but you don't have to put it into standard or general form. It's just a good idea. I'm just going to rewrite it down here. X minus 2y equals negative 19. 5x plus 2y equals 1. Step 2, modify one or both of the equations so that one set of variables are opposites. Okay, we actually don't have to do that in this step. If you look at the y terms, do you notice how we have a positive 2y and a negative 2y? That's what you're looking for. When you get one set of variables to be opposites, then elimination is going to work. Combine the equations to eliminate a variable. All right, so here's what happens. I like to think of it as like a big addition problem. We're going to combine the variables. X plus 5x is 6x. Negative 2y plus 2y cancels out. So we've eliminated the variable y. And then negative 19 plus 1 is negative 18. And now you're going to solve for x. So x is negative 3. Now when we do this, we're going to take negative 3 and put it in for x on either of the two original equations. I'll use the first one. Negative 3 minus 2y equals negative 19. So I'm going to add 3 to both sides, which makes it negative 2y equals negative 16. And then I'm going to divide both sides by negative 2. So y is positive 8. All right, my ordered pair solution is negative 3, positive 8. And then when you plug this back in, they should both work. So we would do negative 3 minus 2 times 8. Well, that's negative 3 minus 16, so that is negative 19. And then on the other equation, 5 times negative 3 is negative 15, plus 16 is 1. Okay, we're in good shape. All right, 3x plus 4y equals 18, and negative 2x plus 4y equals 8. So we've aligned everything, and like terms are matching up, but step 2, there's a problem. We don't have variable opposites. One thing we could do is, I see that there's a positive 4y and a positive 4y. Those are very close to being opposites. How about I take one of the equations and I multiply it by negative 1. When I do this, it'll turn that positive 4y into a negative 4y, and then we'll have our opposites. So I'm going to rewrite my first equation. 3x plus 4y equals 18. And then the second equation I've multiplied by negative 1. So that makes it positive 2x minus 4y equals negative 8. Now we're going to combine. 3x plus 2x is 5x. Positive 4y minus 4y eliminates. And then negative 18 minus 8, positive 18 minus 8 is positive 10. Divide both sides by 5, and x is 2. Now take 2 and put it in for x on either of the other two equations. I'll put it in the first one. So 3 times 2 plus 4y equals 18, which would make it 6 plus 4y equals 18. So 4y equals 12, and y is 3. So my x is 2, my y is 3, the ordered pair would be 2, 3. Moving on. Try this on your own. Press pause and see how you do. And when you're ready to check your work, press play. Alright, so for my step 1, I have everything lined up. X's are lined up, Y's are lined up. I don't have opposite variables though. How about this time, I'm going to try and eliminate the X's. So if I have a positive 2x and a negative x, to make these opposites, I could multiply the second one by 2. So that'll give me 2x plus y equals 3. I've just rewritten the first equation. The second equation, after multiplying everything by 2, is negative 2x plus 6y equals negative 24. Now I'm going to combine. Positive 2x minus 2x eliminates. Y plus 6y is 7y. 3 minus 24 is negative 21. And I'm getting that y is negative 3. Now take y equals negative 3, substitute it, so I'll put it in the first one. 2x plus negative 3 equals 3. So how about we add 3 to both sides, which makes it 2x equals 6. Then divide both sides by 2, and x is 3. My ordered pair solution is 3, negative 3. All right, next problem. This one's a little more challenging. Everything is lined up, which is great. I don't see any obvious variables that'll cancel out. So you have to choose. Do you want to cancel out the x or the y? I'm going to choose to cancel out my x's, just because. You can do the y's, it doesn't really matter. I'm going to do the x's. If I have positive 7x and positive 5x, you want to try and multiply both equations, and you need to find a common multiple. So the least common multiple of 7 and 5 is 35. So that means maybe I can multiply the first equation by positive 5, and it would look like this. 35x minus 60y equals, I have to do that off the side, negative 22 times 5. 5 times 2 is 10. 10, so 110, or negative 110. See, it's totally okay to do arithmetic off to the side. Okay, second one. I want 35x, but not only 35x, I want it to be a negative, so it will eliminate. So 5x, I'm going to multiply by negative 7. So that'll make it negative 35x plus 56y equals, and again, I'm going to do a little multiplication off to the side. 7 times 4 is 28. So this will be positive 98. When you combine, you should get that negative 35x and negative 35x will cancel, or positive 35x and negative 35x will cancel. Negative 60y and positive 56y will give us negative 4y. Negative 110 and positive 98 will give us negative 12. Divide both sides by negative 4, and you'll get that y is positive 3. Substitute y back in. Okay, so that would be, I'll put it in the second equation. 5x minus 8 times 3 equals negative 14. So 5x minus 24 equals negative 14. Add 24, and you'll get that 5x is positive 10, and x is 2. So our solution will be 2, 3. Okay, so that's going to do it for the day. In class, we'll do lots of practice on both of these methods. I find that the more you practice, the better you get at them, and the quicker you get at them, for sure. So have a good day, and I'll see you next class.